All right, we're going to look at chapter 2, looking at chemistry. There's two parts to this chapter. First, basic chemistry, and then we're going to look at biochemistry. So let's start really simple, and that's defining matter. Matter is anything that occupies space and has mass. And matter and mass are different than weight. Weight is taking into effect the mass that matter has and the effects of gravity on that mass. There are three states of matter: solid, liquid, gas, and they can be defined as follows. A solid has a definite shape, a definite volume, so bones and teeth, a table, your pencil, whereas a liquid has a definite volume but a changeable shape. Blood plasma and other liquids take on the shape of their container. And then you have gases. They have a changeable shape and volume. You can pressurize gas. The air we breathe is a great example. We can also define energy. And you can't see energy, but energy is the capacity to do work or put matter into motion. So you can see what energy does. You can see the results. So you can really only measure energy by its effects on matter. So the greater the work done, the more energy is used doing it. There's two types of energy: kinetic and potential. Kinetic energy is energy in motion, energy in action. If you were to suddenly stand up because your skeletal muscles contract, that's kinetic energy. And the potential energy your leg muscles have, which was inactive, now becomes active. And so that's a switch from potential to kinetic. And energy can change back from kinetic to potential and vice versa. Another example of kinetic energy is a push on a swinging door that sets it into motion, pushing the pedals, riding a bike. If you've ever been on a roller coaster, you've experienced the potential energy build as you go up a hill. And then when you go over that first hill, you are converting, or seeing the conversion really, of potential energy into kinetic energy. We can see that here. Initially, potential energy goes up, and then once you go down the hill, kinetic energy increases. And there's a back and forth interplay between potential and kinetic energy. That's because energy can be transformed from potential energy to kinetic energy, because stored energy can be released, and that results in action, or kinetic energy. There's also different forms of energy: chemical, electrical, mechanical, radiant. Chemical is pretty simple. We're going to talk the most about it. It's going to be energy stored in bonds. So chemical energy is stored in bonds like that of ATP, which is known as molecular energy. ATP can be broken down in order to release energy. So you break bonds to release energy. The full name for ATP is adenosine triphosphate. Electrical energy is the movement of electrons, particles, generally between ions. And when we talk about ions and forming ions, we're looking at the transfer of electrons. So electrical energy, it makes sense that it's called electrical when it's the movement of electrons. Mechanical energy involves directly moving matter, such as, again, pushing pedals on a bike to move it. And radiant or electromagnetic energy is energy that travels in waves. So radio waves, X-rays, ultraviolet waves, visible light, all of those are examples of radiant or electromagnetic energy. All right, next we're going to be looking at the composition of matter. We're going to define things like atom and element and chemical and molecule. So that's going to be in the next video.